Right, this asks a truck covers 40 meters in 7.05 seconds, while uniformly slowing down to a final velocity of 2.25 meters per second. First part wants us to find the truck's original speed. So I find it easy to go ahead and write down what we know. We know that the displacement, or the distance covered, was 40 meters, 40.0 meters. And we know that it took him, the change in time was 7.05 seconds. And lastly, we know that his final velocity is 2.25 meters per second. So how can we go about finding the original velocity? Here's what I like to do. I like to draw a graph on these kind of problems to help me visualize it. So this is my velocity axis, and this is my time. And we know that whenever you have velocity chart against time, the distance is always the area under the curve. So we know that it lasted for 7.05 seconds, this event. He started off with a speed of unknown, so we have an unknown speed somewhere up here, and the final speed right here was 2.25 meters per second. So this is 2.25. And here's what happened. He decelerates, and then he probably levels out. So, but this right here is the area we're interested in. We want to know what this starting speed was. And so in order to find the starting speed, we kind of need to know a little bit more. We know that this area in here, this distance covered, the total area under the curve should equal 40 meters. So if I break this off into two geometric shapes, I can draw a rectangle that is 2.25 by 7.05. So I can work that out mathematically. It turns out 2.25 times 7.05. This area should be 15.86 meters. So if I know that my total is 40, then I know that this area up here is 40 minus 15.86. So how do you get to that, which is, let's just go ahead and work it out. 40 minus 15.86 is 24.14. 24.14 meters. And so the question is, what kind of math can I go about to express all of this area in terms of the final velocity? Well, it turns out that the area of a triangle is the base, which is 7.05, times the height, which is some unknown height minus 2.25, right? That's the height. So this height, we don't want to know all of this height, so all of that height would be x. We want to chop off this much of it, so x minus the 2.25. So x minus 2.25 times 7.05 times 1/2, base times height divided by 2, should equal 24.14. So we can work this out algebraically. So I set up my problem. The first thing I'm going to do is multiply both sides by 2. That will cancel this guy out, and it will take this guy to 48.28. So this expression, then I can divide both sides by 7.05, which would cancel him out. So 7.05, and that would make this guy 6.85. 6.85 meters. Okay, so the total meters minus the initial, or the final velocity, the total velocity minus the final velocity, this is meters per second, is 6.85 meters per second. So if I add my 2.25 to both sides, I can find out what my initial velocity was. So 6.85 plus 2.25 is 9.1. X equals 9.1 meters per second. And I think whenever I plugged this into my problems on the WebAssign, I was a little bit more exact on decimals, and I had 9.098. It accepted that. I know that it doesn't have to have significant figures, so any range of numbers should work, but 9.1 should work. The other thing it wanted to know is it says find its acceleration. So during this, let's go back to this graph. What is this acceleration? The acceleration equals the slope, right? So what is the acceleration? So acceleration equals v final minus v initial divided by the change in time. So the v final, we figured that the v initial, we figured out what it was, is 9.1. The v final, it gives us is 2.25. So I can put in 9.1 meters per second minus, I'm sorry, I'm doing this backwards. This is my initial, so I need to put v final. So 2.25 minus 9.1, and these are in meters per second, divided by the change in time, which was 7.05 seconds, and that should give me my acceleration, which is approximately negative 0.97 meters per second squared. And there's the two answers to the problem. That's how you work them.